Hello everyone, in this video I'm gonna discuss an sample problem in the topic of thermodynamics in heat transfer. So this is in heat transfer chapter 10, the heat transfer by convection. So here is the problem. A 0.4 watt cylindrical electronic component installed on a circuit board with dimensions of 0.3 centimeter in diameter and 1.8 centimeter in length. So it is cooled by air flowing across it at a rate of 150 meter per minute. So find the component surface temperature if the ambient temperature is 40 degrees Celsius. So let's list down all the given in this problem. And in this one, we assume that the film temperature to be 50 degrees Celsius. So the properties of air at 1 atmospheric and at this temperature are found in the table -15. So we have here, we gathered all the values given in that table. So copy it. Okay, let's proceed to this. First, let's solve for the Reynolds number. So here is the equation of Reynolds number. So let's just substitute the given in that equation. So calculating this all, we're gonna have this final answer for Reynolds 417.1. Next is the proper relation for Nusselt number corresponding to this Reynolds number. So this is the Nusselt number. So corresponding to Reynolds number, we have this equation. So this is a very long equation, but you can find this in the book. So you'll just read in the book and you'll get this equation. And that equation, we have here the Reynolds and Prandtl. So let's just substitute the numbers to this equation. So we have here substituting the Reynolds 417.1 and then the Prandtl number, which is given in the previous slide, so 0.7228. So we have here calculating this all and we'll get this 10.43 for our Nusselt number. So let's proceed to the next. So the heat transfer coefficient is this. Let's use this equation. This is from the Nusselt number, and let's just get this heat transfer coefficient, which is the H. So substituting all the gathered values in the previous slides. So we have here calculate this all, and we'll get the heat transfer coefficient in this one. So 95.09 watt per meter degrees Celsius. Then the surface temperature of the component becomes like this. So let's first we get the area of the cylinder, which is pi times the diameter times its length. Because it is now given, let's just input the values in the equation. So we have here the area 0.0001696 meters squared. So to get the temperature, surface temperature of the component from this equation of the convection, I mean. So let's all get the surface temperature. So surface temperature is equal to the T infinity plus the rate of heat transfer over H times the area. So in this equation, let's substitute the given values. Let's calculate this one and we'll get this final answer, 64.8 degrees Celsius. So that's it.